Good afternoon, everybody. Firstly, we'd like to thank GRAPHISOFT, extend a big thank you for inviting us here to share our story with you all and to be part of such fantastic company over these 2 days. We've entitled our presentation Analysis, Automation, Evaluation. We come from Liljewall Arkitekter in Sweden, and we want to share with you how we work with architectural design based on empirical data. My name is Kristen Broberg, and I'm a senior architect, partner, and head of BIM and digital development. I'm here together with my colleague and architect, André, who is responsible for the development of data-driven design at our office. I hope you've had a chance to see him in action in the Reimagine Zone over these 2 days. And before he shows you how we are working, I would first like to give you a brief introduction to Liljewall. We are one of Sweden's largest architectural offices, owned and run by the employees. We have our head office in Gothenburg, where we are located, as well as offices in Stockholm, in Malmö, and in Buenos Aires. There are 20 different nationalities working at the office and an equal mix of men and women. Equality and diversity is very important to us in all that we do. We were established in 1980 and currently consist of 220 architects and other professions supporting the architectural process. We have doubled in size over the last 4 years. We are driven every day by our vision to create architecture for people that creates a better world. Our size allows us to work broadly in both scope and size of project. We work in different studios throughout the office, each with its own business area. Everything from urban planning to housing design to landscape architecture. Here is a quick selection of some of our work. All of the projects are located in Sweden, from the far up in the north in Gällivare down to the southern tip, and from the east coast to the west. To support each of the business areas, we specialize in fields that make for a better architecture with a focus on the client, on the user, and on our future. BIM and D+ is at the core of all of the work we do. Next year, we celebrate our 40th anniversary. Having come from Australia as a graduate architect in the year 2000, I've worked at Liljewall for almost half of that time. And I've been first-hand involved in our transition from BIM and beyond. I could spend ages talking about this subject, but I will keep this brief, and you guys can look me up, come and see me if you want to know more afterwards. Back in 2011, we were a technically competent office of about 50 people and very good at documentation and ARCHICAD, but saw a need to change. So it wasn't BIM that was driving us then. We didn't even talk about BIM. But what we talked about was that we are architects creating three-dimensional buildings. Why on earth are we drawing in 2 dimensions? It didn't make sense at all. How do we communicate to clients in 2 dimensions? How do we have quality control in 2 dimensions and understand space? So that is what drove us to make a change. In 2002, we began our first ARCHICAD project, and then we proceeded to implement that across the whole office in each new project that was started over the coming 3 years. ARCHICAD gave us the potential to do so much more than just documentation, though. And around about 2011, we tried to market BIM to our clients, and show them what was possible with the information in our models and the way we could work together. But they weren't mature enough to do more than 3D CAD or clash detection, if that. And there were still many thinking that 3D would cost a lot more. So we focused on developing our internal process to reap as much benefit as we could and stay ahead in the game. It took a while, but in 2016, and since then, there has become an increase in awareness and requirements of BIM on the part of clients and contractors. It still varies a lot, of course, and probably has a lot to do with the lack of national BIM standards and common practice in Sweden. We have extended our practice and our process to using BIM models for climate and life cycle analysis and populating them with information for the contractor to work in various areas such as production, planning, cost estimating and purchasing. As architects, however, our greatest strength is the effective process we have established in working in ARCHICAD right from the very beginning to support the decision-making process, and also the way everyone involved in the project can work creatively together and effectively as a team within the model, not as separate designers and modelers, as many would perceive our profession. We do have a challenge, however, as we have clients today that don't understand the way we work in our projects and in our process, and there is a tendency towards closed BIM. However, today and in the future, the workflow with data-driven design through Grasshopper and Rhino is strengthening our capacity and ability to work smarter and more efficiently in an early design stage, and with a particular focus on sustainability. Now we have our team, which we call D+, a play on the programming language of C++ and adding extra to design. It's headed by André, and they're developing our new workflows and creating new business opportunities. We have plans in the latter half of this year to train and spread this knowledge across the whole office. So I'll let André take over and show you what this is all about.
Vilken knapp är det? Den stora, okay. Thank you, Kristen, very much. What you see in the picture is the team we have within the office that is working with Grasshopper and the development of these different tools. So what I'm going to talk about is our digital tools and workflows and how we as an architecture office are using data to design, make decisions, and engage with our different clients. And part of being a group developing these tools are creating these kind of new types of workflows for the office. And these tools, they stretch from everything to automation of parking spaces to generative urban master plans. And we use these tools in all different scales. So I'm going to showcase examples going from urban scale to block scale to plan scale. One of the things which is very crucial for us is accurate 3D models. And we use these models to test and evaluate our different design within. What you see in the background right now is a mesh model inside of Rhino. And we extract these from Google Maps through Python scripts which we created, which automates the process. And this makes this takes away a lot of manual work, which we usually spend to create this contextual environment. And we do this in order to quickly get up and running, to gain the contextual insights we need when starting a new project. So, and we apply these models in three categories along our workflow, and starting with analysis, that we use this model in order to understand the context for which we are designing in order to design within it. And we're looking at things like existing buildings height and street experience and day water collections. And then the actual design itself, where we are testing hundreds of different variations, seeing how well they perform and how they fit within the actual context. So it helps us to explore the whole design spectrum of possibilities. And finally, we evaluate these generated designs by looking at how well they perform and viewing them through different metrics. For example, like in this case, we're looking at unobstructed views and daylight accessibility. So a big thing of our focus is visual representation of data and engagement. And our goal is to present data in a way which people can feel is understandable and believable. So this way of working requires us to think in new ways. And one of the tasks is to create traditional design thinking and workflows into algorithms and logic. And what that means is that we have to see traditional processes and kind of mimic them into mathematical thinking. And for example, in this case, having an urban master plan design tool, which genuinely lets you explore many different new designs. It's quite a complex task to create, because when you start to program something like this, you can't have any initial thought about how the final design should look like, because you're more creating an environment where the algorithm can create different designs into. So it's more of creating a process than actual final designs. One of the things we have in the office to make our Grasshopper scripts accessible to all the architects is that we create these widgets or apps or UIs, which lets the architects streamline many more tedious design processes. And we can use these together with Rhino and ARCHICAD to contextualize the methodologies that we create. So for example, here that we look as an isovist of a floor plan, and doing this kind of simulation allows us to understand the space in new ways by maybe asking questions of how good is the connection to the windows when you're within the plan, and how easy is it to navigate in this space. So through using these tools, we're able to make more informed decisions faster. This is the workflow we have going between ARCHICAD, Grasshopper, and Python, actually, which we're mainly programming in, and these HTML windows, which lets you control and trigger Python definitions within Grasshopper, so you can move in between. The first thing we're going to look at is show a methodology for urban scale tool, and this tool allows you, This tool allows you to manually draw primary streets that are in the top hierarchy in urban planning. And the idea behind this is that you're able to sketch and test out many different variations very quickly. And design tasks that maybe would take days to create earlier, now we can do it in a couple of minutes just to test out different proposals. And the computer the algorithm then generates many different proposals within this. And you can then manually, if you decide, okay, I like the way that block is looking there, so you can manually lock it and then let the computer generate within the other surrounding blocks around it. And this we're able to do also by using Python, so we're getting past the linear data flow in Grasshopper, so we're cutting it off in the middle and actually storing the temporary Grasshopper geometry within an object or class inside Python. So the next step for developing this tool, which we actually started, is that we want to get more away from the whole automatic portion of automation and actually giving more control to the architects and the designers. So the algorithm should actually only be there as an assistant and not the dominant designer. We look at the generated proposal in different layers to capture the complexity of the space. And this is how the algorithm is working, that you create these lines and you're able to rotate them, and it subdivides all the parcels within between. So when presenting this to a client, we can run through different proposals and discuss the different metrics and how the special characteristics are. And finally doing a special test fit and looking at, for example, in this case, with daylight accessibility, and also which houses or apartments have visual contact with the surrounding water. Going into block scale, we have more or less the same kind of workflow, where we're assigning different kind of buildings, building typologies into this closed boundary curve. And we're then able to generate different proposals and evaluating how well does it fit within its context. So, and we do not only look at it in terms of numbers and massing, we also then want to bring on the more softer values like design aesthetics. And when we feel that, okay, we're satisfied with 2 or 3 of those outcomes, we then bring it into ARCHICAD to make the final drawings. And lastly, going into plan scale, we'll look at an example for a methodology of generating office layouts. And in this case, we are looking at a conventional layout where we have open desk workplaces along the facade, and meeting rooms and kitchen and the overall core in the middle. So what we have is this space planner, which allows us to create a program for the space. So you can fill in how many people are going to work in this area, how many meeting rooms should there be for every X person, and telephone rooms, and then you generate the program and it tests, does this area fit within the plan? And you get an okay if it's okay. So the next step is our algorithm, that it starts off by dividing the facade into segments, and each segment is given a variable containing the facade length. And then the algorithm randomly decides one of the segments, and it distributes or allocates a certain portion of the program into it. And it keeps doing this process over and over again until the whole program is distributed. And the secret behind this, in order to create, like we're talking about, a tool which genuinely creates new kind of ideas that you maybe didn't think of, is having this random factor, which is just big enough for it to create new proposals all the time. So seeing the system in action, this is what it looks like. And it creates these random designs, and we evaluate all the proposals through different metrics. And we're not doing any kind of optimization here, because we feel that trying to optimize stuff, you always lose some of the factors that you didn't think of. So we're doing this quite open with no set of goals. And what we just want to have is this spectrum of designs. And what we then evaluate them is by analyzing what kind of movement patterns will it be in this plan, and showcasing it through a graphical representation. And this adds an extra layer of information to us. So we can see in the area where the red color is actually the area where probably is going to be most activity. So it's most suitable to place people in the bottom left corner that want to work with not being disturbed, or people that want to work in an open environment can work in the upper corner. And this allows architects and designers to not focus on questions like, will this desk fit in that meeting room, or will this space have enough spaces? We can ask larger questions like, what does this mean if we move this meeting room to this place instead? How does that affect the flow within the plan? And because of this being parametric, we're able to do quite dramatic changes to the overall shape, and the system will then generate an update with it. We use this design explorer, which is developed by Core Studios, where we can then package all the generated design and filter through them and check out which ones do we want to keep working with, and then bring it into ARCHICAD to keep working. And that's the final slide for us. And we want to thank you so much for allowing us to come here and speak.